Hello, I'm Voy, and this is Wojciech. Every single point that the flat earthers are trying to make has been debunked so many times, but still, there are a few that they just can't give up. And here is where we come in. And if you are a flat earther, keep watching, because we're going to talk about your favorite toys, perspective and refraction. Let's begin with the observation of Red's rhetoric at Tampa Bay. Link to the original video is in the description. So here is a picture taken from a relatively close distance, but now when you take a look at the picture taken from further away, you can see that the bottom parts of the building seem to be obstructed by the body of water that's between the observer and the buildings. Why is that? Obviously the reasonable explanation is the Earth's curvature, but the flat earthers say perspective and refraction. Let's take a look at them, shall we? Let's talk about the basics of optics first. So let's take this cube and let's shine some light on it. The light is going to hit the wall and reflect off the surface in all the different angles. And this observer is going to see only this light that has been reflected directly at it, because basically all the other light misses the eye. All this other light doesn't matter. So now let's replace this cube with this nice bar. And here the light rays that are coming from the extremes are going to tell the observer the angular size of the object and its location, like it's in front of it. So now let's make it a little bit more interesting. Let's put a prism in between. Here the light gets refracted by the prism and arrives at the eye. So the question is, what does the eye see? All that the observer knows is that there are these light rays that are coming at it right from this direction, which gives the illusion that the bar is in a different place than it is in reality. The brain is fooled. Oh no, what happened to trusting your own senses? So now instead of this bar, let's take a building and let's assume the Earth is flat. So if there was no atmospheric refraction, the observer would see this building just right at this angle. But in reality, if the observer is far enough, he would only see the top part. Why is that now? The common explanation that the flat earthers use is that from this perspective, atmospheric refraction starts playing a role. The light coming from this building would have to be bent in the atmosphere and arrive at the eye of the observer at the particular angle, which gives an illusion of the building disappearing from the bottom up. Basically because the light that's coming from the bottom floors of the building is blocked by the ground as it's bent in the atmosphere. Let's talk about a bit bigger picture now. We've got these two buildings that are so far apart that because of perspective and refraction, they are going to see only each other's rooftops, even with Nikon P1000. Let's copy it and let's bend it in such a way that would mimic how the situation would have to look like on the round Earth. So now notice that both the observers see exactly the same thing, and there is no way for any of them to tell the shape of our planet just by looking. So what can we do? We can notice that this light path is bending upwards, or we can say it's concave. And we know that this happens only if the refractive index of air is increasing with elevation. The atmosphere acts like a prism here. When we orient it like this, there is more refractive material on the top than there is on the bottom, which gives an effect of increasing refractive index. When we shine light through it, it will bend upwards. And actually this is exactly what happens here. The atmosphere acts like a series of thin prisms, each single one bending the light ever so slightly upwards, giving the light path this concave shape. You might have already noticed that even though these two guys see exactly the same thing, the physical situation is very different. This light path is actually curving downwards, is convex, which, as we know from physics, only happens if the refractive index is decreasing with elevation. And this we can also demonstrate with the prism analogy. And here's the question that we've all been waiting for. Which one of the two is right? Well, the refractive index of air is directly related to air's density. And as we know very well, the density of air decreases with elevation. At least most of the time, because it might happen that locally the refractive index is increasing with elevation, and then we might observe something like that. I'm sure you're all curious what we would see on a flat Earth most of the time. So here we've got the observer on top of one building and a few buildings in front of him. And let's say that the refractive index is decreasing with elevation, like it does most of the time in reality. So the question is, what does the observer see? Like with this prism, the light is bent downwards, and the light rays from the tops of these buildings are arriving at the eye of the observer at the higher angle the further away they are. And the brain is fooled again, because what it sees is a concave Earth.
Oh no, what happened to trusting your own senses?
Wow. Keep in mind that this is what we would see on the flat earth most of the time. So if you have seen anything like that, let me know in the comments. I sure haven't, as much as I would love to. It would have to be gorgeous. Let's sum up what we have learned today. We have shown that the perspective and refraction are certainly not helping things disappear over the horizon. If anything, they only allow us to see further than we normally would on a globe Earth. Now, what other physical phenomena do the flat earthers hijack and misunderstand? Let me know in the comments so that I know what I can take on next. Want more content like this? Please like and subscribe, and remember to share it, especially with your flat earth friends. And I'll see you next time on Wojciech.